Frequently people ask me, how do you read weather maps? And there's many kinds of weather maps, but there's a lot of consistency between them all. I'm Joey Only, the Caribou Weather Dude. It's sunny out today. Snowfall is not really starting till tomorrow. Tonight's our show here on this channel, the Cometeorological Report, Comedy plus Meteorology equals Cometeorology, your show about how much the weather sucks in Canada. Well, we prepare for that. Let's have a boring look at the University of British Columbia's course outline on map interpretation. This map's provided by the U.S. National Oceanographic and Aerospace Industry Ocean Prediction Center. The second image is the same map for the same valid time where I annotated features in this map. So we're going to explore all this one step at a time and focus on the first map. And we'll use the second map to help identify features. The high and low pressure systems are indicated with an H and an L respectively. High pressure turns clockwise, low pressure turns counterclockwise. Recall that lows are associated with bad weather, as in clouds, wind, precipitation, fronts, and highs with good weather, clear skies, light winds. The blue numbers with underlines indicates the central pressure of the high or the low. You can put a decimal point in front of that last digit to get kilopascals. Now the fronts, they're the curved lines with triangles for the cold front, and they're semicircles for the warm front. Cold being blue, warm being red. Both on the same side of the line for occluded fronts, and both are on opposite side of the line for stationary fronts. On this map, cold fronts are blue, warm fronts are red, occluded fronts are purple, and stationary fronts switch between red and blue colors. Fronts usually come out of a low, it's curved like the spokes of a wheel. Cold fronts can have convective clouds. That's thunderstorms, squall lines, spotty, heavy rain showers along them. Warm fronts can have broad areas of stratiform clouds and wide areas of drizzle and light rain ahead of them. Occluded fronts have bad weather similar to both warm and cold fronts. Isobars connect lines of pressure. Isobars, think of it like a topographical map, except you're not looking at a hill, you're looking at a pressure system. They are the curved lines that are shown in brown in this map. The unit of pressure is kilopascals. So 24 means 102.4 kilopascals. 16 means 101.6. 4 means 100.4. 92 means 99.2. 68 means 96.8. That's a little difficult. And how much do I personally use that? Not a lot. But you can insert the decimal point before the last number and put a 10 or a 9 in front of the number, whichever one gives the pressure closest to 100 kilopascals. Now, why do we care about isobars? Because the wind blows almost parallel to the isobars. The closer neighboring isobars are to each other, and the faster the wind speed, the closer they are together. So it's kind of like if you look at close bars on a topographical map, that shows steepness in the feature. So think of it kind of in that regard. The steeper that front coming in is, the more wind, the more explosive it's going to be. On this map, winds aren't shown except at a few ships and islands. Instead, I inferred that the winds are connected to the isobars, and I drew these winds as directions, like black arrows on the second map. In Northern Hemisphere, winds go in a direction such that low pressure is to the wind's left and winds are nearly parallel to the isobars, but the winds cross the isobars at a small angle due to frictional drag against the sea surface. You can see in the second map above that my black arrow showed directions that are consistent with isobar directions. Also, I added fast winds where isobars are closely packed together and slow winds where isobars are spaced out. Warnings for marine weather hazards are abbreviated and enclosed in a small blue box. The first map also shows some other features, including developing fronts and lows and dying fronts. Also, the forecast movement of low centers are shown with red arrows. These are highlighted in the second map above. These features are important for sailors so that you don't accidentally plan your voyage into a location where bad storms are moving or new storms are developing. Here's a different map example for a different date. It's also provided by National Oceanographic and Aerospace. You can see the low pressure system, L, in the Gulf of Alaska. High pressure system, H, to the west of the USA. It tends to live there in the wintertime especially. It's approaching the coast of BC and Washington. A low is just southeast of the Vancouver area. Given these isobars, can you anticipate wind direction and relative speed? Can you see where the highs and lows are predicted to move? In addition to the symbols we already discussed, the new frontal symbol is shown here as a series of check marks. This is a trough of warm air aloft, trawal. It's the Canadian symbol for a type of occluded front. Namely, it has bad weather similar to both warm and cold fronts. When we look at some of the weather station symbols, we're going to avoid looking at the cloud types here. I'm not too concerned about that right now. Partly because in the Navigation Canada maps I like to use, those symbols don't really show up much. You can get an idea of the cloud coverage: no clouds, 0, completely overcast and black. You might see that. Wind direction, I mean, that's pretty obvious. Wind comes from the direction of the arrow. Air pressure, high, low. Miscellaneous sky cover. Again, these are ones I don't see all the time, very often. So, I mean, same with these barometric tendencies. These aren't ones that I come across in the flight maps so much. But these ones I see often. The showers, slight rain, moderate heavy rain. You notice the dots here? 2 dots is violent rain. Got a little crystal here means sleet and hail. You've got a little snowflake, slight snow, moderate snow. And these ones I see, especially the thunderstorms. So you get, rain. These are mild thunderstorms, mild snow thunderstorms, and then hail associated. Don't forget that all rain generally starts as snowflakes up in the sky. People say, wow, it's so crazy. I couldn't believe there was a thunder snow. Well, almost every thunderstorm is a thunder snow if you're at the right elevation. So you do see these thunderstorm icons frequently on the GFA graphic forecast area maps that I like to use. This is weather station model demo. How much do you need to know this? Probably very little. In fact, I've personally never had to rely on this. Definitely if you're going to school for meteorology, they're going to push you on that. You can anticipate changes in weather by monitoring the movements of the fronts and areas of high and low pressure on weather maps and satellite issues. If you see a front approaching your location, you can expect to see a change in the weather once the front reaches you. If you can see a front approaching your location, you can expect to see a change in weather once the front reaches you. Your route may need to be changed or your trip delayed as different weather systems approach you. Barometric air pressure. Air pressure is the weight of the air over the ground, and the unit is kilopascal. Historically, older units have been used for pressure and are sometimes still used on marine weather charts such as millibar and hectopascals. It's easy to convert between these units. Just go to Google. Average air pressure is about 101.3 kilopascals. A high pressure system would give you a reading closer to 103, and a low pressure system might give you a reading around 100. A barometer is another tool that sailors use to help them forecast the weather. It's an instrument that measures air pressure, changes in air pressure which generate winds. A dropping or falling of barometric pressure means an approaching low pressure system or front, and its associated bad weather is coming. A rise in barometric pressure and approaching high pressure system and fair weather, but later calm winds, are associated together. Together with the weather forecast, a barometer is a great tool to help you predict approaching weather. So I hope that little overview just kind of gives you a good refresher on how to read most weather maps. There's one more thing I didn't mention, and that was these little music note clefs. And you see that again here on our map where it talks about wind speed. Now, this will look different on the GFA maps I use, but it's the same. You'll notice that it's upside down here, but that gives you an idea. That's 20 knots of wind coming off that. So that's another one you see pretty frequently. If there's a bunch of the lines, you might have sometimes 30 or more, right? So we've seen wind speeds at 50, 60, 70, 80 knots delineated on our GFA maps with this wind speed. So my name is Joey Olney, KRB Weather Dude. Tonight's our show with Frankie McDonald. Please tune into the channel here at 7 p.m. for the live stream. We're trying to make our show a TV show. We're getting there. Second attempt at a pilot this week. They mostly like what we're doing, so it's going to happen. It's just going to take a bit of working to make those TV people happy, and we're okay with that. That's the creative process. That's how it goes. Please hit like, please hit subscribe, please share, please help me keep growing the channel, because this is what I want to do in my life, really, is just sit around, talk about weather, make videos for all of you, and fight fire in the summer. On that note, we'll see you next time. Bye for now.